All right, hello again. Okay, so the angle of elevation is going to be on the ground looking up. So this is the angle that we're looking for. I'm going to call it theta. So we started this example 2 on the last video, and then I had to cut out for a second, and then it came back. So this is my angle of elevation. So if we're looking at it, the 15 feet is across from the angle, so that would be opposite. And then this side is next to it, so that's adjacent. So if we're thinking about SOHCAHTOA, we're going to use tangent again. So we'll have tangent of the angle theta, which we don't know what it is 15 over 20. Now how do we find the angles again? The little tangent with the -1. So theta, they call this inverse tangent. So it's a tangent with a little -1. On the calculator, you can just put 15 divided by 20. If you wanted to reduce that to 3/4 ahead of time or change it to a decimal, you could. But the calculator will take care of it in the form that it is. So, and, oh, I pushed the wrong button. Hang on. Little technical difficulties. All right, so it comes out 36.869, blah, blah, blah. So if I go back, it wants us to find to the nearest degree. So we're going to round this up to the nearest whole number, which would be 37 degrees. Okay. Back on track. Everybody done with example 2?
Yes.
Okay. So let's go on to the next page. Here we have example 3. An observer in a balloon, which is 2,000 feet above an airport, finds that the angle of depression of a steamer ship out at sea is 21 degrees. Find to the nearest 100 feet the distance between the observer and the balloon and the steamer ship at sea. Okay, so I'm going to draw a balloon up here. I'm going to draw it like a balloon like this, although it's actually like a balloon I think you could get into, like a hot air balloon, but whatever. And it's above the airport, so we're going to draw that line straight down and just call this little dot down here the airport. It's a great looking airport, and it's 2,000 feet above. So that's the main reason why I'm drawing that line. I need to know that distance is 2,000 feet. That's just from this first part of this first statement. And it finds that the angle of depression of a steamer ship out at sea is 21 degrees. So I'm going to kind of draw this line here. This would be the surface of the sea. And here's your boat out here, okay? And then we're going to finish our little triangle. And here's where it's going to be a little different than problems we've done before, okay? The angle of depression from the observer in the balloon is not inside the triangle. When you're doing angle of depression, you have to draw a little pretend horizon line that goes out this way. And the angle of depression is this angle out here, which would be 21 degrees, which they tell us that the angle of depression of a steamer ship out at sea is 21 degrees. The reason for this is the little instruments that they use to measure this, it measures out and you have it level, and then it's like the angle down from looking straight out. So you're looking at your instrument straight out and then it's like down. So how would we figure out what the angle is that's actually in the triangle?
Well,
What would these two angles add up to?
tell us.
These two angles will add up to what? 90. So to find this angle, I'm going to take 90 minus 21, which gives me 69. So this is 69 degrees right here, okay? And that's actually inside the triangle. And then it says find to the nearest 100 feet the distance between the observer and the balloon and the steamer ship at sea. So here's the balloon, and here's the ship. That means this distance right here is what we're looking for. We'll call that x. All right, so there is a little bit extra work. We know when we're doing that angle of depression that we have to draw that horizontal line out, and that angle is actually outside the triangle, but it's not that bad to find the one inside. They just add up to 90. All right, so let's look at what we've got. X is the hypotenuse. I'll give you that one. What is the 2,000? Opposite or adjacent? Adjacent. So which of our trig functions uses adjacent and hypotenuse? Cos, so cosine. So we're going to have cosine of the angle, which is 69 degrees up there, equals the adjacent, which is 2,000, over the hypotenuse, which is x. All right, so we had a little trick that we learned last week after doing lots of these. What can I do to get x by itself? So I'm going to switch the x with the cosine 69. So x is going to go over here. The 2,000 stays up there where it is. And we just did a whole bunch of them and figured out that this was actually a shortcut. Okay. And so I get x equals 5,580.856, blah, blah, blah. So let's go back and see where they want us to round. So find to the nearest 100 feet, nearest 100 feet. So not hundredths, but 100. So this is my hundreds place right here, the 5. Is it gonna? So it's gonna round up, right? Because the next number is an 8.
Yeah.
So we're gonna round it up to 5,600 feet. I started to say 5,600. That's not very mathematical. 5,600 feet.
Go to the bathroom.
Yes. All right. Everybody good on example 3?
Yeah.
Okay, let's take a look at example 4. It says from the top of a lighthouse 160 feet high. Okay, so I'm also going to go ahead and draw my lighthouse. Boop, boop. I'm going to put the light on top. I don't really know what that's going to look like. It's light shining out. There's a window. It's the best lighthouse you've ever seen. All right, so we're at the top of a lighthouse that is 160 feet high. So I'm just going to put a little line over here to represent that height. 160 feet high. The angle of depression of a boat out at sea is 24 degrees. So we're going to draw the surface of the sea, pretending that it's flat. And here's the boat again. And if we draw our little triangle, remember that the angle of depression is actually going to be out here. You draw this little pretend horizontal line. And that angle of depression that's 24 degrees actually goes here. So let's figure out what's actually in here before we read the rest of it. So 90 minus 24 is 66. So it's actually 66 degrees inside the triangle. We've got 160 here. There's my right angle. Find to the nearest foot the distance from the boat to the foot of the lighthouse. So am I going to put x here? No, it's got to go down here because they want from the boat to the foot of the lighthouse, which means the bottom, not the top. So these little details are what allow us to figure out where the x is going to go. Okay, so 66 degrees is here. That's the angle we're going to use. X is across from that. So what side would I label that with? Opposite. And then what's the 160 feet? Adjacent. Good. So I'm using opposite and adjacent. Which trig function is that? Tangent, because we have the toa on the SOHCAHTOA. So tangent, 66 degrees. I want opposite over adjacent, so x over 160. All right, how do we solve that? Multiply both sides by 160. So I'm going to take the left side times 160, and I'm going to take the right side times 160, which cancels this out, and then I just have to put this into my calculator, which comes out about 359.3 dot, 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 dot. And then, let's see, it wants us to round, find to the nearest foot. So what would be the nearest foot? 359. So 359 feet will be my answer. So we're still basically just setting up the triangle. The only thing that's really interesting is figuring out angle of elevation, depression, where to put the angles on the picture. Okay, we've got one more. You guys ready for 5?
Sure.
An airplane which had taken off from an airport traveled a ground distance, which means it's horizontal, of 3,660 feet. Okay, so let's draw that just to get that straight in our minds. So we have the airplane over here. It's taking off like this. I'm going to draw the best airplane you've ever seen. It's going to probably look more like a flying fish.
That is exactly what I was going to say.
Yeah, it kind of does. And so it tells us the horizontal distance it's covered is 3,660 feet. So it's not the actual distance it's gone up here. It'll be close. But if it's horizontal, it's got to go down here on the ground. They call that the ground distance. Okay, it says, what is the angle of elevation from the point of takeoff over here to the point when the plane has traveled 4,150 feet through the air? So it's traveled actually this far. And this is the amount of ground it's covered underneath. And they're wanting the angle of elevation where that takeoff point is. So that basically tells you that the angle that we're looking for is going to be over here. Okay, so if we label the sides. What side is the 4,150? That's the hypotenuse. And what's this side down here?
Adjacent.
Adjacent, very good. And so if we have adjacent and hypotenuse, we're going to use which one? Cosine. So I have cosine of theta is 3,660 over 4,150. And we can reduce that if we want to, but our calculators will actually take care of this for us. How do we find angles?
Cross -1.
Ah, the inverse cosine, which is the one with the -1. And so we can type it into your calculator like this. We've already done that several times. And it comes out that theta is about 28.12, and there's other decimal places. It says round to the nearest degree. So we'll just round that off to 28 degrees.